exponents. And quite frankly, this is something that you guys dealt with in junior high. So it's one of those things as a teacher I think kids struggle with, but usually the kids feel confident with, which almost makes it worse because if you don't know what you're doing but you think you do, you're actually more dangerous than if you know you don't, if that makes sense. So anyway, we'll kind of go through this probably fairly quickly, but if you have questions, make sure you ask. So when we have an exponent, b of a, b is the base and a is the exponent. An exponent is shorthand for repeated multiplication. So if we have n to the fourth, that means we will multiply the base of n by itself 4 times. So expand each of the expressions below. For example, x to the third, which means the base x times itself 3 times. So this would be the base y times itself 7 times. 4, 5, 6, 7. This would be x to the third twice, right? And inside each of these would be 3 x's. So altogether, you're actually looking at x to the 6th. I had a professor, actually a teacher, I don't know, professor, anyways, when in doubt, write it out. And I think that that's really worth doing on these if you don't know the shortcuts to exponents, if you struggle. When in doubt, write it out till you do know. It makes it way easier. Long story short on this one, a lot of times kids get confused. That 4 is to the first power. We never mention something is to the first power, but if it's to the second or the fifth power, we do. So there's only one 4 there, but there are 5 x's, and there are 2 y's. Oh, geez, I skipped this one, sorry. And again, there's 1 5 there, and there's 3 2m's. So if you think about that, it's like 5 times 2 times 2 times 2 times m times m times m. And then we could just say if we wanted 10, 20, 40. Well, actually, I guess they want it to expand it. They don't want us to simplify it. So we'll just leave it like that for now. We would simplify later, but they're asking us to expand it and write it all the way out. So hopefully we see why those are what they are. All right. So Miss Wing has just explained to her class how to write the simpler expression using the giant the number 1 or giant ones. I don't know if you guys have dealt with these before, but essentially if we get something that looks like this, I'll kind of clear up some room here. So let's say we have x squared times y to the 8th over x times y to the squared. So if we expand these things, it's x times x, 1, 2, 3, 4, 5, 6, 7, 8 y's over 1x times y times y. Well, think about it. What is x divided by x? It's 1. And what is y divided by y? It's 1. And y divided by y is 1. Anything divided by itself is 1. So we've turned these into giant ones. And what's left on top is x and 1, 2, 3, 4, 5, 6 y's. There's nothing on bottom, so we would say like to the first, but you don't really need that. So this becomes x times y to the 6th. So that's what the giant ones are. And again, when in doubt, write it out. There's obviously faster ways to solve this problem. Way faster ways to solve this problem, right? You can even just think in your head, oh, 2x's are going to fight 1. Well, the 1x on top will win. And 8 y's are going to fight 2 y's. The ones on top will win by 6. And that would be fine. But sometimes kids don't see it that clearly. And I would say, again, if you're not sure, go ahead and write it out. It should make it easier. So explain why y to the 6th is simpler than Miss Wing's starting expression. Well, it's been simplified. You've gotten rid of, you've reduced it, right? It would be like 2 to the 4th. You've reduced it to 1/2. So we've reduced this down. Rewrite each expression below. And again, x divided by x is 1. So this would be x squared. Here, and again, I'm going to kind of go to I guess I'll write out a couple of them, and then I'm going to go to the shortcut. So I have 5 x's and a y and 2 x's. Well, these x's will cross each other out. I have 1, 2, 3 x's and a y on top, and just a 1 on bottom. But again, we don't really need that, so it's just x third y. Now, if we look at this, kind of the rules are that if they're on top together, they kind of hang out. So this is really 3 w's plus 5 more w's. That's really 8 w's because we're saying w times w times w times w times w, 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 w. That's 8 w's. and there's 2 W's on bottom. Now, if they were to fight, the ones on top would obviously win, and they would win by 6, right? 2 W's would cross out. 2 W's on bottom would cross out 2 on top, and there would be 6 left over on top. Here, I would say be real careful on these. Kids always seem to get a little confused the rules between the bases and the z's. And if we look at that, this is just a simplified fraction is all that's going on here. What is 16 divided by 8? It's 2. And if I have 3 z's on top and 2 z's on bottom, well, the z's on top will win by 1. And that's how I write my z's, by the way. So my answer here would just be 2 over z. So the giant 1 can also be used to simplify scientific notation. Start by expanding the expression like Miss Wang did, and then show how you use the giant 1 to write the equivalent expression in simpler form. Be sure to use your simplified expression in scientific notation. I'll tell you what, long story short with these, I look at these as 3 problems. 1, I look at the bases. 2, I look at the exponents, and then 3, I put them in scientific notation if I need to. Remember, scientific notation needs to be between 1 and 10. So if I look at these ones, what is 12 divided by 4? It's 3. What is 9 tenths over 3 tenths? Well, 3 get crossed out, and we have 10 to the 6th. Right? Again, if we write that out, 12 times 1, 2, 3, 4, 5, 6, 7, 8, 9 tens over 4 times 1, 2, 3 tens. This cancels out and turns into 3. These cancel out, and I'm left with 1, 2, 3, 4, 5, 6 left, right? I hate writing all that out. I won't do that very often, but I do want you to visually see how we get 3 times 10 to the 6. Well, on this one, kind of tricky. What this one's really saying is it's saying I have 2 of these 8 times 10 to the thirds over 4 times 10 to the first. I hope we see that. Well, 8 times 8 is 64. And if I have 3 tens and 3 more tens, I actually have 6 tens over 4 times 10 to the first. Well, think about it. What is 64 divided by 4? It's 16. And if I have 6 tens divided by 1 10, right? 6 tens on top, 1 on bottom, 1 cancels off. I have 5 tens. So again, this becomes like 3 separate problems. 1 is dealing with the bases. 2 is dealing with the exponents. 3rd is putting this in scientific notation. Our number can't be 16. It's got to be 1.6 times 10, right? Well, think about it. If I'm going from 16 to 1.6, I'm adding another 0, right? So this should be 1.6 times 10 to the 6th. Excuse me 1 second. All right, sorry about that. And again, just where we left off at, this is going to be not scientific notation. This is scientific notation. So again, 3 steps. Deal with the bases, deal with the exponents, then deal with putting it in scientific notation. Over here, we dealt with the bases, we dealt with the exponents. We were already in scientific notation, so we could be done at that point. All right, so at that point, let's go ahead and answer some of these other questions. It says some of the equivalent expressions below are correct and some are not. Expand the expression using giant 1s to justify whether or not each pair of expressions is equivalent. If they are not equivalent, identify the mistake and correctly simplify the expression on the left side of the equation. So if it's not equal, we'll fix the left. Well, over here, we have 3, 7, 8. I'm sorry. We have 7 H's and 1 K. And over here we have 12 H's and 1 K. Again, we don't multiply those together. That's like saying I have 3 H's and I multiply it by 4 more H's. So that's only 7 H's. So I guess this would be correct if I made this 3 and 9. I'm sorry. If I made this 3 and 8. H to the 8 times H to the 4th. Now I have 12 H's and 1 K. So I had to fix that one. B. Again, I'm going to simplify the basis. 39 divided by 3 is 13. I have 2 P's on top and 4 P's on top and 2 P's on bottom, so they fight. The 2 P's on top win. Here I have 5 Q's and 2 Q's, they fight. 3 Q's on top win. Yeah, this one is equal. So I don't know. I guess we'll just say it's equal. I don't even know what to put here. On this one, Well, if I have 2 nines on top and I have 3 nines on bottom, you can see I'm left with an extra 9 on bottom. And contrarily, if I have, so I guess let's do the whole thing here. If I have 5 threes on top and 2 fives on bottom, I have a 5 on top. So again, I'll do this whole thing at once. I probably should have done the whole thing at once anyway to make it a little bit more clear. But on top, I have 2 nines. And on bottom, I have, and on top, I have 3 fives. On bottom, I have 3 nines and 2 fives. And now I'm going to cancel out in giant ones what I can, and I'm left with 5 nines. So yeah, these are equal. All right, how about this one? Well, I have 5, 6, 7 threes. I don't have 7 nines. I have 7 threes. So this should be 9 to the 5th times 9 to the 2nd equals 9 to the 7th. That would fix that. Remember, they told us to fix the left side, not the right side. All right, on this one. What is 9 divided by 0.5? 9 divided by 0.5 is 18. And then 10 sixes on top and 10 sixes on bottom, they're all going to cancel each other out. So it's just 9 divided by 0.5 is 18. So these ones are equal. As crazy as that looks, those ones are equal. If we go here. So what's going on here is I have 2 W's on top and 5 W's on bottom. And when I cancel that, I should have 1 over W to the 3rd. So it told us to fix the left side of the equation. So I guess if I put an 8 here instead of a 2, right? 8 divided by 5 would give us the 3. So I've got to fix that one there. Let me clear up some room here just to finish this. Okay. So if we go here, this one's kind of a pain. So this one is going to be 7 times 10 to the 3rd times 7 times 10 to the 3rd, right? I have 2 of these things over 3.5 times 10 squared. That's just going to stay the same, but this is actually going to give me 49 times 10 to the 6th over 3.5 times 10 squared. So the question is, this 10 to the 4th looks fine to me, right? 6 tens, cross out 2 tens, I'm left with 4 tens, but 49 divided by 3.5 is not going to equal 2. What this thing needs to actually equal is 7 altogether. So how am I going to fix this thing? That's a great question. You know, here's how I'm going to fix this thing. I got it. I'm going to go over here and just really change the whole thing. I'm going to get rid of the square completely. So I'm going to make this 7.0 times 10 to the 6th over 3.5 times 10 to the 2nd. That's how I'll fix this thing. 7 divided by 3.5 is 2. And then I have the 6 tens and the 2 tens cross out and give me this over here. So I'm not even going to mess with the other exponent. Seems like too much trouble. All right, here. Again, if I deal with the bases, I'm not going to write all this out. But you can see if I have 50 G's here and 5 G's here, they're going to cancel out. There's going to be 45 extra G's on top. And then these will cancel out and just simplify as a fraction. So it'll be like G over 45 equals 2. So actually these are equal. Again, I guess if we just attack it one piece at a time, I hope you all agree. I hope you all agree that 5 divided by 10 is 1 over 2, right? I can make that 1 over 2. And that 50 G's, and if I cross out 5 of them, there's going to be 45 G's left. So those are equal already. And this last one, a little bit interesting. I'm basically saying I have 4 x squareds. And if I have 4 x squareds, what I really have is 8 x's, not 6 x's, right? So this would be correct if this was a 6, but I can change this to a 3. If I change that to a 3, then I lose one of these and one of these. and I'm sorry, I hope you can see through it. So I have 2, 4, 6 x's. So again, just making that one change, x squared to the third power instead of the fourth power. We'll go ahead and make that one work. So kind of a long section already. I hope we're feeling a little bit okay with these. I know these aren't the easiest things, but hopefully we're doing okay there. And we will go ahead and finish up 131 by these last couple. I think I already did these ones, right? Good. I thought I kind of looked at this and was thinking I was going to have to go through all of these again, but I've already done all those. So I'm just down to 167. So 167 says, work with your team to write 4 expressions with exponents, each equivalent to x to the 12th. So, I mean, you could be as lazy as you want on this. You could say x to the 13th over x, or x to the 14th over x squared. Or if you wanted, you could get a little bit more exciting and go something like this, x squared to the 6th power, or you could say like x to the 3rd to the 4th power. There's a bunch of different ways that we could do this. So like I said, be as creative as you want. I used some multiple, you could say x to the 5th times x to the 7th. That would be another way that you could get that. So a bunch of different ways we could get it. There are some notes on scientific notation, so if you feel like you need to brush up, I would strongly encourage you to take a look at those.